Right then, this is the last question on the handout, and it's 2001, part B. Again, it's coming a bounce down a plane. So we have a ball this time dropped onto an inclined plane. It's dropped from a height of h. It strikes the plane at P and it rebounds. The plane is inclined at 30 degrees to the horizontal, and it says that the coefficient of restitution between the ball and the plane is a half. Okay, so it's a bounce question again. Coefficient of restitution is mentioned. Now, it hits the plane at P and then it bounces off down here. It says how far from down the plane from P is the ball's next point of impact. So this is position P. How far from P is the ball's next point of impact? So really what you want to find is the range from P. So once the ball strikes the plane at P, what's the range after that? Okay, so what I'm going to do is, first of all, turn that plane around so I've got some kind of a velocity to work with. I'm going to make the plane an y-axis. This, of course, then is 30 degrees. And the ball is coming in, so it's falling directly. It's going to fall directly. That's your centre of the Earth. So it's falling directly, vertically down onto the plane. So if I turn the plane around, that means it's coming in like this. So the ball's velocity, it's dropped from this position here of rest, u is 0, and when it strikes the plane, it's travelling with a velocity of v. So here's the v. Here it comes in, and then when it hits the plane, of course, it's going to rebound. And this is the bit I need to find. So this rebound bit will correspond to that bit there, and then I'll be able to get the range for the second part of the motion. So first things first, let's find out what the incoming velocity is. So this is my incoming velocity v. I'm going to divide it into its two components. I'm going to draw a right angled triangle around that, and I'm going to identify the I component and the j component. So I'm going to need an angle. Okay, so remember this v, which is dropped vertically onto the plane, that's going to make a right angle with the ground, with the earth. So here it is here it comes in. That's going to be a right angle here, which means that this angle here is dot. By the alternate rule, this is also dot, which means the angle that I'm interested in is that one there, maybe 30 degrees, because that's also, of course, going to be a right angle. Okay, so that means that my incoming velocity then is this I component is opposite the angle 30. So this I component is going to be v sine 30, and the j component, because it's adjacent to the angle, is going to be v cos 30. Okay, so they're my two incoming velocities. Of course, this is in the negative direction and this is also in the negative direction. Okay, so my incoming velocity, so the first strike onto the plane, the incoming velocity is what? It's minus v sine 30 in the I direction, minus v cos 30 in the j direction. And of course sine 30 is a half and cos 30 is root 3 over 2. So this will become minus a half v in the I direction, minus root 3 over 2v in the j direction. Which means that when it hits the plane and bounces, this outgoing velocity then is, remember, going to be, it's an I-axis strike. So the I will stay the same, minus a half I, minus a half v, and the j component, of course that sign will change to a plus. I'll multiply it by e, and that will be root 3 over 2v j. So, and when I do that, I know that e is a half. That means that my outgoing velocity is minus a half vi plus root 3 over 4 bj, because e is a half. Right, so this now is my velocity here after the first bounce, the first strike, and I want the range. So I need to draw up a table. I'll get my ij components for my table. The u is this incoming velocity here, which is minus a half v, and the j part is root 3 over 4v. The acceleration due to gravity, the a, here it is, so there that would be the g. So I'll break into its two components and I'll get rid of this. So of course this I component here will be g sine 30, and this j component will be g cos 30. So this a will become minus g sine 30 minus g cos 30. Now, I'm going to remember that it's down a plane. So in big red letters, I'm going to remember to change the sign for my v. T's arbitrary. Right, v. V is going to become u minus a half v minus g sine 30t. And because it's going down the plane, I'm going to take that minus out of the way, and that will be a half v plus g sine 30, of course, is a half again t. So I'm taking this minus out of the way now, which means that that I component is positive. Only happens with the I component, doesn't happen with the j component. So this will just be still minus g cos 30, and cos 30, of course, is root 3 over 2 t. Now my s will therefore be a half vt plus a half by a half g t squared, and this will be root 3 over 4 vt minus a half by root 3 over 2 gt squared. So my s, the I, is a half vt plus a quarter gt squared, and this will be root 3 over 4 vt minus root 3 over 4 gt squared. Okay, so I have all my information on the table. The question I'm asked in here is to find the range. So I want the SI when the SJ is 0. So I'm going to take my SJ, which is root 3 over 2 VT. I'm going to put that equal to root 3 over 4 GT squared. Divide all the way across by T. Get rid of those root 3's. And that will give me T is equal to, what is T equal to? That SI, when SJ is 0, this should be a root 3, oh, sorry, I've changed that to root 3 over 4. It should be root 3 over 4. So the 4's will cancel, the root 3's will cancel, so the T will just become V over G. So I'm going to put that T into the SI, and that's going to become a half V by T, which is V over G, plus a quarter G by T squared, which is V squared over G squared. So that gives me a half V squared over G plus a quarter V squared over G, because that G will cancel with that squared. So I'm going to get 3/4 V squared over G for my range. So this is the SI. The SI. Nearly there. Question says express your answer in terms of H. Now, what was H? So at the very beginning it said that this ball was dropped onto the plane a distance H. So here's my plane. The ball was dropped down onto this a distance H above the plane. Of course, it fell freely with acceleration due to gravity. It struck the plane with a velocity of v. It was let fall, so the u was 0. So if I could, what I need to do is express v in terms of h. So I need to get rid of this v squared. So using this bit of information at the very beginning of the question, u is 0, s, or the distance it falls, is h. It's falling freely under gravity, so the a is equal to g. That means that if I use v squared equals u squared plus 2as, that will give me an expression for v squared, which I can sub in here. So v squared is equal to, u squared of course is 0, 2, acceleration due to gravity g, and s is h. And then when I put that v squared in here, it will become 3 over 4, v squared is 2gh, over g's will cancel, 2 will go in there, and that will give me 3 over 2h.